So Jared, thanks for talking to us today.
That's okay, no worries.
Now, I believe you're going to let us into the clean room.
Yeah, we're going to have a look inside the clean room today. This is where I do a lot of my work. So,
Why is it called a clean room?
it's a clean room because it's specially designed to minimize the amount of particles in the air.
Right, so how many particles are in the air in there?
In there, depending on the area, roughly 1,000 particles in a square meter.
That's not very many, really, is it?
No, it's very few.
And so you put all the sensitive equipment in there?
Sensitive equipment and equipment that needs to be cleaned for sort of extended use and for gluing and assembly.
Am I clean enough to go in there?
As you are? No.
So what have I got to do?
So we'll take you through that. In here we've got our changing vestibule. So you'll change into the clean room equipment. We'll go through some sticky mats and we'll get some static off you and it should be okay.
All right, well, let's do it. Here we are in the clean room. I feel very clean. And I don't look nearly as cool as Jared does. Let's have a look at Jared.
That's how I set it up, really. I mean,
Like, that's clearly the greatest uniform I've ever seen in my life. How often do you wear this gear?
depending on what we're doing, if we're producing some detectors or something, every day.
What do you actually do here?
Well, I suppose basically I make the machines that go ping.
The machines that go ping.
Yeah, they go ping, and then you can, from that, determine what type of particle has gone through it and track them and things like that.
So, and what's your actual job title here?
Well, my job title currently is Research Fellow or sort of a Research Assistant Grade 2. From time period to time period, it varies a lot. Sometimes I'll be in here 8 to 12 hours a day constructing these particle detectors for use overseas. Sometimes I'll be working on computer programs that go on the back end of some of these detectors, and sometimes I'll be overseas working with other groups, helping them to construct things and to calibrate their various detectors. So last year I worked in Switzerland for about 8 months, and that was a lot of fun.
So are you actually a qualified physicist?
No, but don't tell anyone.
What's that?
Well, this was something that was specifically designed and built at Melbourne University to create SCT modules. An SCT module is a particle detector that's going to be used in the ATLAS experiment over in CERN. So this is our Mitutoyo Quick Vision Pro metrology machine. So basically it is used to measure stuff. So it's a really expensive optical mirror, optical measuring system, I should say. And we can use this for image recognition. We can align to surfaces, and we can measure the distance between 2 points to an accuracy of about 0.2 microns.
How big is a micron?
25 microns is roughly the width of a human hair.
So we're talking really small.
Tiny, tiny. We measure computer chips, and we also measure our placement of computer chips.
So Jared, what's this machine?
So this machine is our wire bonder. So we use that to hook up all of the components that we've put together and measured previously.
And how does it work?
Well, if you have a look down here, there's a little tiny needle down there. That needle has got a little bit of wire that's coming out from underneath it, which is fed from a spool up there. So that wire, currently we're using 25 micron wire, so about the same width as a human hair. So that uses an optical image recognition system, and then that can find the wire bond pads and then come down, and it uses ultrasonic vibrations to melt the wire.
So this is in effect a real sonic screwdriver.
It's a sonic screwdriver.
That is the coolest thing I have ever seen in my life. Thanks a lot for having us down here, Jared.
That's okay, it was a pleasure.
It was a lot of fun going into the clean room.
I'm glad some people can derive pleasure from it.
I just want to know, can I keep these clothes?
It's all disposable, so you can do with them what you want.
Awesome.